Today we are going to be looking at dilations and rotations. So first we will look at dilations. So there's my title for the notes, dilations and rotations. So last class we looked at translations and reflections. This class we're going to be looking at dilations and rotations. Those are all four movements: reflection, translation, rotation, dilation. So far we've had a flip and a slide. So with a dilation today, a dilation is when we either make it bigger or smaller. So the words that you will see for this, for bigger, this is an enlargement. So you can see the word large in there. Enlargement makes it bigger. And for smaller, it's going to be a reduction. You reduce the size. So these are the words that we will be seeing with a dilation. It's either an enlargement or a reduction. And so you can see the picture here, it starts small, it gets big, it gets small. That's the main point of a dilation, is it's either growing or shrinking. So for math talk, for our dilation, it's going to be a D for dilate, and then you'll have a number down here as small, and then your point X, Y. All you do for a dilation is multiply each point by this number down here. So for the new one, I would have N times X, and then N times Y. And that would get me my new point. So here, all this means is multiply. Okay, so let's look at an example of a dilation. So here we have our shape, our triangle, and they gave us the ordered pairs. And then here is the rule. The question says, given D2, let me make that look like a 2 and not a Z. Given D2 for triangle PZG, draw triangle P prime, Z prime, G prime, the new triangle. So the first thing we need to find is what's called the scale factor. This is going to be the number that we multiply by. So again, to find the scale factor, we want to go to the D and look at the little number next to it. So here it's a 2. So our scale factor is 2. Since this is bigger than 1, this is going to be an enlargement. I can't fit it all. Oh no. Slide it over a little bit. And enlargement, because that's bigger than 1. If it were a fraction, like 1/2, 2/3, then it would be a reduction. So if it's smaller than 1, it's a reduction. Bigger than 1 is an enlargement. Most of what we'll see this year are going to be enlargements, whole numbers. So if we go to draw our new image, all we do is take every number here and multiply it by 2. Multiply by 2. Multiply by 2. So if I do 0 times 2, I would get 0. Negative 2 times 2, negative 4. My next point, 2 times 2, positive 4. Negative 1 times 2, negative 4. Negative 2 times 2, negative 4. Oh, I did one of these wrong. Negative 1 times 2 is negative 2. Sorry. And then positive 1 times 2 is a positive 2. So these are my 3 points for my larger triangle. So when I go to draw these, for G prime, my new G, I'll go to 0 and then down to negative 4. Then P prime, I'd go over 4, down 2, over to 4, down to 2. And for Z prime, I'm going to go back 4, up 2. Back 4, up 2. That would be my Z prime. And so then you can see our new triangle. You can see how here it's larger than the old one. So those are dilations. It's getting bigger or getting smaller. This is the only one that changes size. Reflection, rotation, translation, all the picture just shifts, slides, flips. We're about to see what we're doing. So our last one we're looking at is a rotation. So you can see here with the rotation, this is something that is going to turn. So for a rotation, this is going to be a turn. So let's take a look at a couple different, we're going to get to the rules in a minute because there's a lot of them. But first, let's just look at a simple little picture with some words. So here we have a 90-degree clockwise rotation. So 90 degrees is going to equal 1 turn. Clockwise goes in the direction a clock goes. So it spins to the right. And here we want to rotate image or point C. So here if I find point C, I'm going to take it to the right 1 turn. So if I take point C to the right 1 turn, I end up at point D. So that's the turn. It's just going to spin. On the next one, I have 180 degrees. So here you can see that's a half turn. So it'd be, we think of 90 degrees as 1, 180 would be 2 turns. So, and we want to turn point EF. So here if I take EF and I turn it 1 time and then I turn it 2 times, I end up on the other side here, GH. And then the last one is another 90 degrees, but this time it's counterclockwise. So if clockwise is to the right, counterclockwise is going to be to the left. And here we're looking at AH. So here, oh, this is a funny line, AH, and we just want to turn it 1 time. So when I make 1 turn, I might end up here on this other funny line of DG. So hopefully this just helps you to see how when we turn, we're just spinning. We're making 1, 2 turns. So on the next part, you will want to write these down. These rotation rules are really weird. So I would write these down, put a big star by this to make sure you have these, because this is going to help you know what your new point will be. So for 90 and 270, the X and the Y are going to switch spots. So these will all flip positions. And then on clockwise, my X is going to be opposite for 90, and my Y is going to be opposite for 270. And then for counter, my Y will be opposite for 90, and my X will be opposite for 270. And then for 180, it's the same for both. It's going to be normal order XY, but both will be opposite. So again, here, if you want to draw arrows to help you, clockwise is to the right, counter is to, I'm going to get a good arrow, the left. And then here, I'll give little notes to help. 90 would be 1 turn. 180 would be 2 turns. That means 270 would be 3 turns. Okay, I know that's a lot. So let's look at one to see if we can use this to help us. Okay, so we have 3 points, and I'm going to start by putting these on the graph. So point E is at 0, up 3. Point F is over to 3, up 1, 2, 3, 4, 5, all the way at the top. And point G is over 4, up 0. And then I'm going to connect my dots. And then if we look, we've got a 90-degree counterclockwise. So that means 90 means we want 1 turn, and counterclockwise means we're going to go to the left. So I'm going to take this picture and turn it 1 corner. So it'll end up over here. So if I look at 90 degrees counterclockwise, I'm going to use this rule for example 2. So I want all of my points, the X and the Y will switch spots, and my Y will become opposite. So here for E, originally it's 0, 3. So for my new E, I'm going to write 3, 0. So the X and Y switch. And then Y, since this is positive, it's now negative. For F, I start at 3, 5. So I want to flip and have 5, 3. And then my 5 will be opposite. And same for G. Starts at 4, 0. I'm going to switch. So now I have 0, 4. And 0, 0 is just 0. That can't be negative. So I'll leave 0 as it is. And then I can put these points on my graph. So for my new E, I'm going to go over negative 3 and then up 0, over negative 3, up 0. This is my E prime, so you can see this E made 1 turn down. F prime over negative 5, up 3, over negative 5, 1, 2, 3. So again, that F made one turn. And then my last point is G over 0, up 4. Over 0, up 4. This is my new G. So again, here's my new triangle. And you can see here, it's just like I took this F and I pulled it down 1. So that's rotation. So the main part is going to be using this table for your rotation rules. So make sure you have this written down. And again, I'll put these notes in Google Classroom so you can always pull this up to look at these notes. So do you have clockwise, do you have counter, and then what number are you moving? All right, so go ahead and take a look at the practice and see